Good afternoon, everybody. Welcome to a cloudy, overcast Wednesday afternoon of Chem 170 with your host, me, Dr. White. All right, couple things. First of all, a public service announcement from Dr. White, in case you missed it. If you go to the assignment area of Blackboard, you will see extra credit project. And if we look at it, the extra credit project is 10, hold on. 10 bonus points. Now, how do you get the bonus points? You can find 10 organic molecules that are in the ingredients list of commercially available products. You can use a molecule only once in the chart, and you can get up to 3 molecules per products. It's my sneaky way of making you look at other stuff and a couple more than just one item. And to get full credit for that molecule, all entries in a row of the chart must be correct. For each entry, record the name of the product, the name of the molecule you're talking about in the ingredients list, and name, if it's more than one functional group in that molecule, you only have to name one. And if there's only one, then that's the one you got to name. And be sure you put your name on the chart. Actually, you guys don't have to, because when you upload it to Blackboard, the file name includes your name. But it won't hurt. All right, here's an example. First column product, second column molecule, last column functional group. And brand X wine has ethanol, which is an alcohol, and you get 1 point. 9 more, you get your 10, yes, 10 points. Now, to make this interesting, you cannot use the following molecules: sucrose, ethanol, isopropyl alcohol, acetone, ethyl acetate, propane, acetic acid, and methane. Also, you can't use the following products: beer, wine, vegetable oil, vinegar, gasoline, propane, natural gas, orange juice, milk, sugar, butter. Everything else is fair game. Now, important, the ingredients must appear on an ingredients list on the product, and they must contain a functional group discussed in this class. There are other functional groups that I did not discuss that are in daily products, but those are out of bounds. Why? Because that time when I didn't do that, people would pick a functional group they didn't know, and guess what? They always got it wrong. So this protects you too. Now, this is due by the end of the day, uploading it as a PDF file, May 5th of this year. No late projects accepted. And again, please upload it. Now, this is an optional project. You don't have to do it. But if you do, you can get 10 big bonus points, which even if you're getting an A, it's good insurance to have 10 points in case you needed it, even if you don't. All right, now beware. Not all names on labels are UPAC or common names. Some of them are marketing, and some of them you're not familiar with. Simethicone, ooh, O-N-E ending, Dr. White told us that's a ketone. No, that's a silicone compound. Like I said, not all names are UPAC or common names. Now, how can you find out what functional groups are in a molecule on an ingredient list? Look it up in Google, or you can ask me. Now, as a public service, oh, by the way, when you use Google, put in the name of the chemical or substance, then add the words chemical structure. And one of the first 5 hits will usually always be a chemical structure. And now you know how to read those. Now, as a special special service to you, public service, I highly recommend before it's due, if you're going to enter one, or send it to me by email and I'll look at it. And any problems, I'll let you know so you can fix it. That way you can get your 10, let's see, yep, 5 and 5, 10 bonus points, which is like getting 10 more points on one of your tests, which is a good thing, real good thing. All right. Next thing I need to talk about is I looked at the schedule. I remember a while back, I said, well, we got to take some of the lab time to catch up. By the way, ketchup has stuff you can use on the list. Mustard too. So same thing with barbecue sauce. I'm giving everything away. Excuse me. But anyways, I was looking at the schedule this morning and saying, oh no, guess what? Which is a good thing. We're way ahead of the schedule. So today I'm going to let you out early. We're still up to date, but things are going good. I'd rather be ahead of the schedule than rushing to catch up. Even though ketchup is organic, you know what I mean. Oh, it's weird, awful humor Wednesday. You and I both have to suffer through it. All right. Let's see. Oh, one other important announcement. Next Monday, I should have done it today, but I forgot to do it on Monday. So we'll do it next Monday. I will go through the fats and oils problem set. Hopefully you've all worked on it. Hint, hint. Because I think it's 2 weeks from today is test number 4. Boy, this semester is going like that. Way too quick. All right. Oh, one last thing. I got an email, and you probably did too, and that's for student evaluations. Please fill it out. But a better thing is, if you really like what I did, go to ratemyprofessor.com and put down something. I'd appreciate it. If you really didn't like what I did, well, you should do the same thing. Go to ratemyprofessor.com. Now, if you really, really, really like what I did, send an email to the Board of Trustees at ECC. If you really, really, really didn't like what I did this semester so far, send an email to the Board of Trustees. I think I have an important email address. If not, I'll send it out. It's on the website. But anyways, all right, since we're ahead, I figured, I rushed through things. And I've got time to do a few things that I rushed through. Plus, I think I forgot to tell you. Did I tell you about the Procter Gamble story with the perfumer? Thumbs up if I didn't. If you can't remember it, give me a thumbs up. All right, I'm going to tell it. All right, I should have told this when we were doing quaternary ammonium salts, but I was trying to catch up, even though there wasn't any quaternary ammonium salts in ketchup. I told you it's Bad Humor Wednesday. That was pretty low. But anyways, a long time ago, I was section head of nitrogen derivatives for Axochem E for all of North America. One of our top customers was Procter Gamble. And I get a phone call from the VP of Marketing and Sales and said, P&G, just Procter & Gamble, we call it P&G and so today, just changed the formulation of Downy, which is a product they used a lot. I mean, a lot of our product. It was millions of dollars per year we sold to them, a lot. And when they reformulated it, they bought from us and also our competitor. At that time, that was Sherex. And they said, in this new formulation, our quaternary ammonium salt makes it stink. What? It makes it stink. So I said, whoa, that's not good. And his name was Tom. I don't know if he's still alive or not. He was a lot older than I was at that time. Tom Daley said, we got to fix this, fix it. So I got a sample of ours. I got the new formulation. I smelled it. I couldn't smell any difference really. And I set up an odor panel. And my colleague who I worked for at P&G was a research manager like I was, uh, said, set up a smelling panel, but make sure there are no pregnant women on there because sometimes their noses, because their pregnancy, don't work well. Okay, so we did, and we couldn't find a difference. And because it was such a big, important customer and a lot, I mean, millions of dollars involved, millions, tens of millions, more than that, uh, I started getting calls from the president of AXO in the United States. The overall CEO was in Europe, and he would call the president and the president would call me when I get in the office right before lunch and before I left. Did you solve it yet? And we tried all sorts of things, and we were just spinning our wheels. After about 3 weeks of me getting calls every day and everything, I called up the VP marketing and sales and I said, look, I got to talk to who's ever telling us this is bad at Procter & Gamble because I have no way of knowing how to solve this. I'm getting nowhere. So took a little doing, and finally a meeting was set up between myself. I'd be there with our salesman for Procter & Gamble. Our research chemists never go into a client alone. And I agreed with that totally. I was wondering with the salesman. And also it turned out the VP of marketing and sales, Tom Daley, came. And a couple of days before that meeting, a senior vice president from Procter & Gamble called me. I'd never talked with this guy. I talked to people at research, and he said, the meeting you're having in 2 days, couple of things. First of all, if you're a smoker, and unfortunately at that time I was, you can't smoke for 24 hours before you meet this person because it will ruin his nose. Even if you wash and everything, there's still smoke in your beard and everything that never comes out. As a smoker, I didn't know about that, but all right, I'll do that. And the other thing he told me is be very polite, because if you get them upset, we're going to stop buying from you. Whoa, this guy was treated like royalty. And I asked the gentleman, well, my counterpart was that in your research, he'll be at the meeting. He said, no, we don't allow many people to meet senior perfumers. I said, he has to. And I just thought of his name, Dr. Wall. He should be there too. And he thought about it and said, all right, I'll pull some strings. I mean, these perfumers were so protected. People inside Procter & Gamble were not allowed to interact with them unless they're a very select few, because their job was what a product smelled like yesterday will smell like today, and it will smell that same way tomorrow. And it was all done by their nose. They have instruments that measure, but they're not as good as your nose for these trained professionals, senior perfumers. So we had the meeting, and there were like about 10 people in that meeting. There were some more people at Procter Gamble showed up. And essentially it was just me and the senior perfumer, and everybody else were bystanders. And I asked them, we've been told that our product makes your new formulation a downy stink. And he said, no, that's not right. I said, oh, all right, tell me what's the problem. And this is the expertise this gentleman had and how sensitive his nose was. He said, with the new perfume and formulation, your quaternary ammonium salt makes the level of perfume smell a little less. I can tell it, and it's less, and that we can't accept that. I can't. And he had the power to stop things going forward if he wouldn't approve it. So I said, thank you. All right, now at least I know. And we talked a while, and he even told me something that wasn't a joke, but you might have thought it was. He said, something yesterday, I smelled something that was so strong, it blew out my nose. I might as well have gone home. Nobody laughed, because he was being serious too. So with that in line, I said, all right, and something you don't know, but I do, companies have a way of getting their competitors' samples. And I'm not going to say how, but all companies know how to do that. And we got a sample of our competitors' quaternary ammonium salt. We got the formulation from P&G with both ours and the competitors, because I also asked for that. So it was done correctly by their standards, not mine. And we couldn't smell anything. I couldn't, but some people could, barely. Well, at least we knew what we were looking for. So we analyzed it, and I was working with an amazing analytical chemist. He was older than me too. He was in charge of the analytical chemistry department in our research center in McCook when it was still there. Dr. Chunan Wang, amazing person, great person too. And I was working with them, and we were able to analyze and find out what the difference is. And we were talking about a side reaction impurity that our compound had 200 ppm parts per million. Our competitors only had 100. So once I found out what was the impurity, I know how to reduce that. So I reduced it to 0. We sent to Procter Gamble, and by this time, Procter & Gamble were allowing the senior perfumer to call me directly. I mean, that was a big thing. Big thing. And the senior perfumer said, no, now your product, the perfume is too strong compared to your competitors. The problem was they originally formulated the new formulation with our competitors' quaternary ammonium salt, not ours. I let our VP of marketing and sales, how'd you let them do that? They should have been using ours. And he said, you're right. Well, anyways, so once I found that, we were able to adjust the reaction. I can't tell you it's a trade secret. If I do, you have to be shot. No, I'm just kidding. But it's a trade secret. I'm still under a non-disclosure agreement that I really can't tell people that. But we were able to get it the same level, which was 100 parts per million. Everybody was happy. I stopped getting calls from the president. He actually will one last call and thank me for solving that, because we were talking about close to $100 million in sales, and the profits were quite high. All right, that's my story. I didn't have a chance to tell you. That was probably 6 weeks of grief in my life. That was not fun. Those days were not fun until I solved it with the help of Dr. Chunan Wang. And then when everybody was happy, we went out and partied hard. You don't know, chemists know how to party hard. All right, now, what I'd like to do now is go back and cover some things that students have difficulty with in monosaccharide chemistry. And the first one is this equilibrium, how glucose forms its cyclic hemiacetal form. I hope you enjoyed that story. And it's one of those that while I was living it was not a fun time of my life. It really wasn't. Once we solved it, then I was happy. All right, this is glucose. Now, let me remind you the following reaction you learned for test number 2. And the reason I'm going over this because students, for whatever reason, it's not that simple, that's good reason, always have difficulty with this. Oops, wrong place for that. See, even I have difficulty with it, not really. Now you learned right here for test 2, take an aldehyde or ketone reacted with an alcohol acid catalyst. Keep your eye on the carbonyl carbon because that's where all the fun is. And what's attached to it, our prime or hydrogen, our double prime stays there. This opens up to a hydroxyl group, oxygen, and R. This is called the hemiacetal or hemiketal. Well, if you look in glucose, it's in equilibrium. This is called the intramolecular reaction. Intra means it's in the same molecule. And a lot of times when that happens, you don't need a catalyst to make it go at a reasonable rate. Well, here, what happens is this hydroxyl group is this, or alcohol. And here's my carbonyl. And like this attacks the carbonyl to form the hemiacetal. This is at C5, carbon number 5, because this would be 1, 2, 3, 4, C5. And this comes in and attacks. Did you ever think about how violent organic chemists are? It attacks that carbon, and it does. And what you get whatever is not involved in the reaction, guess what? Stays the same. The carbonyl, which is this right here, has the hydrogen on there, and this oxygen will now be bonded to it, and it will have, like you see up here, a hydroxyl group. So this is important. The hydroxyl group attacks the alcohol, really, because there's a carbon here, attacks and bonds to the carbonyl carbon to make the hemiacetal. And if you didn't form this right here, we wouldn't have any starches in our life. That's sad. Now, this is fructose. And as I mentioned the other day, you can get it from corn syrup. They call it high fructose corn syrup. And it's the sweetest sugar available. And the same reaction aldehyde or ketone. If R prime is H, it's an aldehyde. If R prime is carbons, it's a ketone. Plus an alcohol, acid catalyst, you will get, keep your eye on the carbonyl carbon. That's where all the fun is. Remember, Dr. White at heart is a carbonyl synthetic organic chemist. What's attached to that carbon is still attached. You get a hydroxyl group, oxygen, R. Now here, again at C5, this alcohol will attack this carbonyl, just like this attacks the carbonyl there. All right, what's not involved in this reaction stays the same. Now this attacks this carbon, which means this will be bonded to that, and which is this carbon right here. And it will also have a hydroxyl group. And this should be a 2, not a 3. Sorry about that. And if this doesn't happen, we wouldn't have table sugar, sucrose. So these are two important reactions that you should know. If on a test I give you fructose in this double-headed arrow equilibrium, you should be able to write the hemiketal. If on a test I give you this, you should know how to develop glucose. Go backwards is a synthesis problem. All right, now, a couple things that I showed you, but I'm not going to go through it in detail. And if you take glucose with other glucose molecules and you use an enzyme that has acid catalyst, you'll make starch. You should also know you take glucose and fructose and react together, you'll make table sugar. And finally, well, actually two finallys. Next, the linkage in starch, and here too, are NaCl ketal linkage. And here's an acetal / ketal linkage. And what does that mean? Well, from test number 2, if you take an acetal or ketal and you react it with acid and water, remember your stomach has hydrochloric acid, H+, and it has water, you'll get back the aldehyde or ketone you would have used to make that acetal or ketal plus the alcohol. Now, starch is held together by this kind of linkage. So if I take starch, like in your stomach, you've just eaten French fries, potato chips, you know, the good stuff, rice or potatoes, all the good stuff in life. And if you eat it, what do you get back? Glucose. Because glucose is really this alcohol and that aldehyde connected together in the same molecule. Now, if you take sucrose and add acid and water, you get 2 compounds. You know something? I haven't been sharing the whole afternoon. Bad, Dr. White. So I'll let you figure out what are the products when you react sucrose with acid and water, like in your stomach. Now, hint, And it looks like everybody's done. So I better get to work. Well, when you eat sucrose, like if you put sugar in your tea or on your oatmeal, Dr. White likes both, it breaks down your stomach to give you glucose plus fructose. And that's that. And that's my quick review. Now, since we're way ahead of ourselves, don't tell the dean I'm doing this, actually you can, because I stole time from our lab Wednesdays to do lecture, but you still had your lab time, but I can do something since we're way ahead of ourselves, which is a good thing. It's lab time. First of all, does anybody have any questions? All right, it's lab time. Don't forget Monday, I'll be going through the fats and oils and the problem set. And the following Monday, I'll go through the carbohydrate problem set. By the way, did anybody think about that your hands are chiral? Did you hold it up to the mirror and see this hand? You saw the reflection, which is your left hand, or vice versa. All right. Let me just get ready because I'm not ready. All right, it's lab time. And this was an interesting lab I thought up that is something that students find interesting. Well, I said it was an interesting lab, duh. But anyways, there's an important rule of thumb, which I taught you, especially important when we're talking about how soap works, which I think I'll go over again next week. It's so important, but for now, and that is like dissolves like. It's on this thumb. Can you see it? And a rule of thumb is something that's most of the time, like 95% is true. There are exceptions. Now, a law in chemistry or science in general is always true. Well, like dissolves like is a rule of thumb, but it's mostly true. And it describes that polar substances are soluble in other polar substances and that nonpolar substances are soluble in other nonpolar substances. If you mix them together, polar and nonpolar, they're not soluble. You get a heterogeneous, two different layer mixture. Now, water is probably the most polar substance in our universe. Hexane is a very nonpolar substance, which is similar to gasoline. Gasoline has octane and other things in it. And nowadays, gasoline is a very complex mixture or solution. Now, in this lab, you'll determine if various substances, such as products that you use or materials you use in your daily life, are polar or nonpolar. This will be accomplished by determining if these substances are soluble in water and if they're soluble or not in hexane. And if a substance is soluble in water, then it's polar. If it's soluble, substance is soluble in a hexane, then it's nonpolar. Now, before I go to the next sentence, remember this is a rule of law, and sometimes things are soluble in both. But for the most part, it's true one or the other. Now, finally, you will determine if certain pairs of substances create homogeneous mixtures, i.e., are soluble in each other. By the way, IE, if you've never seen that before, is Latin. I forgot the Latin words, but it means that is. And it's used by professionals like me. So what you're going to do is mix things together first in water and see if it's soluble, and if in hexane, is it soluble? And that will help you determine based on like dissolves like. Remember, water is polar, hexane non-polar. And if we're doing this face to face, I'd warn you hexane is flammable and be careful with it. And we never ever light matches or Bunsen burners in our organic lab, but still wise to tell you. And the way you would do this lab is in our small test tubes. You put, in this case, for the first part, about this much GI water. You don't even have to measure it out with a volume with a graduated cylinder, just about half or less. Then put about 10 drops of liquid or a small amount of solid in the test tube and mix it. Now, there are two ways of mixing a test tube. This word test tube, hold it firmly and go 1, 2, 3, 4. Don't tickle it. You really have to hit it. Never ever would a test tube mix it this way because you can get chemicals on you or people around you, like the instructor. That's not good. It's not good to get it on you either. And you can look, does it stay homogeneous or not? Now, in our lab, and this is sad because they're fun to play with, if we were there, we'd put out what's called vibro mixers. And they're these little rubber discs with a motor base, and I have it set up for touch on. And here's the little, assume the top of my hand is the rubber disc. Take the test tube, hold it firmly, push down, just set the vibrate real quick, much quicker. And that stirs the test tube. They're fun to play with, a lot of fun. Now you know I'm a chemist. And then let it sit for about 2 minutes and look, is it the same throughout or are there 2 layers? And if the same throughout, it's soluble. If there's 2 layers, it's not soluble. And that's what you're going to do. And unfortunately, since we're not face to face, here's what the results are. Notice we got some interesting things: acetone, baby oil, ethanol, ethyl acetate, 2-propanol isopropyl alcohol, and octane, sodium chloride, starch, sugar, vanillin, Vaseline. I have you do it in a beaker because it's almost impossible to clean out of a test tube, and vegetable oil. Oh, that reminds me of 2 stories. One is when I first wrote this lab, and for about a year or 2, one of the things we tested was car wax. And guess what? It was soluble in nothing. And it was almost impossible to get out of a test tube, like really impossible to clean it out. That stuff's good stuff on your car. And so the lab manager, Dr. Daley, came to me and said, do you really have to do the car wax? Your lab is throwing out a lot of test tubes because they can't clean them. I said, you know something, you're right. Let's skip it, take it out. And I did. Speaking about car wax, I'll do something in a second. Now, in part 2, you'll do the same thing, but instead of using water in the test tube, you'll have hexane. Fill it about this much of the test tube, and then put a small amount of whatever you're going to test, shake it, or I don't have it on here, but I tell you face to face, use the vibro mixer, and then mix it, check and see, is it homogeneous or not? And if it is, it's soluble, well, it's the same polarity as the mixture, the solvent you're putting it in. Hexane, nonpolar, water, polar. And here's the results. Now, for some fun, to make this lab interesting, I have some key pairs to mix. And you do the same thing. Mix 1 or 2 milliliters or so of the first item, add some of the second, and then mix it and see if it's homogeneous. And what are we mixing? Well, the first one is baby oil and vegetable oil, baby oil and starch, vegetable oil and starch, Vaseline and vegetable oil. Why you'd want to do that, I don't know, but it was interesting to come up with these pairs, ethanol and vanilla, and ethanol, vanilla, then add DI water. The last two, if you're not sure, if you have in your house a bottle of vanilla extract, look at the ingredients. And here are the questions. Now, one question students get wrong, so I'm going to help you out a little. Number 4, it says grease is nonpolar. If you do not have any soap and you got grease on your hands, what substance that you tested would remove the grease from your hands? Don't forget, you want your hands clean. You don't want other stuff on it now that you got the grease on it. That's my hint for you. Oops. All right, one last thing, which I don't think I ever told you about, because we've never really used this semester. And I think you see on the screen now, NaCl, sodium chloride. That's table salt. That's stuff you put on French fries, or when you're cooking, you put into the different dishes. Now, if you ever go out to lunch, breakfast, lunch, or dinner with a chemist, and not only organic chemist, but any chemist, and I've been out, invariably one or more of us will ask, can you please pass the NaCl? NaCl? Well, look at the sodium chloride and say it, NaCl. And I have to admit, I've been guilty of that many times myself. Could you please pass the NaCl? And that's today's lab. Like I said, we're well ahead of ourselves, so that's why I can let you go early. And it's probably one of the few times I'll ever do this. I'm done. So with that, I'll say, gehen gesund. Don't forget, tonight from 5 to 6:15, I'll have my office hour. And also, don't forget to hand in a lab that's due today. And I'm done. Gehen gesund. Goodbye. Have a great rest of the weekend. I'll see you on Monday. I'll do the fats and oils problem set. If you're needing help, I'll see you tonight in my office hour. Gehen gesund. Bye.